today's class. Today's topic is number system. Already this chapter we completed. Okay. Today I will tell you some important concept, important problems from this chapter. I will tell you, and I will tell you how to solve those problems also. So the first problem, how they can ask is, okay, they will give two distinct rational numbers and they may ask any n number of rational numbers in between those two rational numbers. Okay, in the previous classes we already learned in between any two distinct rational number there will be infinite rational numbers will exist. We already know that. So based on this concept they may ask any questions. Okay, so how will be the questions? So I'll take an example and I will solve how to solve those examples also I will tell you. Okay, so suppose find find 10 rational numbers. 10 rational numbers. Okay, find 10 rational numbers between 2 by 3 and 5 by 2. Okay, 2 by 3 is different from 5 by 2. These two are two distinct rational numbers. It is satisfying. So in between these two rational numbers, infinite rational numbers will exist. So in that they are asking to find only 10 rational numbers. Very easy. Correct or not? So how to find out those 10 rational numbers? So before going to that, what we have to do, we have to observe the denominators first. So here the denominator is 3, here the denominator is 2. So denominators are different. So first you have to make same denominator. Okay, no? So how to make it? The two denominators as same is, we should take LCM. Okay, so 3 to LCM. What you have to take? 3 1s are 2 as it is. Okay, 3 2s are 6 is the LCM. Okay, what is the LCM for 3 and 2? 6 is the LCM. Directly also you can find out 3 2s are 6. So 3 and 2 rational LCM is what? 6. Directly also you can say, because very simple problem this is. Very simple values. 3 2 LCM is 6. So next what we have to do, we should make denominator as 6. For that what we have to use? We have to use equivalent rational number concept. Means we can multiply same number, non-zero number with the numerator and denominator. Okay, now the resultant number will be equivalent to this one. Is it clear? Yes. So for that, if you want to make 3 as 6 means what you have to multiply? For this rational number we have to multiply by 2. For this one we have to multiply by 3. Okay, now what the result will get, no, that will be equal to this one. So the new rational numbers will be what? 2 2s are 4, 3 2s are 6, and 5 3s are 15, and 2 3s are 6. So now you just observe in between the denominators are same. Okay, now only the numerator are different. So in between 4 and 15. Okay, now how many numbers are there? Just you count it. If 10 are there, then we got the answer. If less than 10 are there, then again we have to go with the one more step method. One more step we have to solve. Then you will get the 10 rational numbers. So in between 4 and 15, how many rational numbers are there? How many numbers are there first? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 10 rational numbers are there. So easily you can find it. Okay. So how we can write? The 10 rational numbers are 10 rational numbers are, what are the 10 rational numbers? 5 by 6, 6 by 6, 7 by 6, 8 by 6, 9 by 6, 10 by 6, 11 by 6, 12 by 6, rational numbers are. If suppose instead of 10, if they are asking 14 or 15, find 15 rational numbers in between. Okay, now in between 2 by 3 and 5 by 12. So in that time what we have to do? Okay, now so we can't go with this one. Means same procedure only. One more extra we should add. Okay, now what it is? See, when denominators will be same, we should observe the numbers in between the numerators. Okay, now if it is greater than the numbers, here 10 numbers are there, but we need 15 numbers. So what you have to do? This one you should assume it as an n. Okay, now just I will tell you what is that n, why I choose it as n. Okay, so we have one concept. Okay, now if you want like a rational numbers, any number of rational numbers if you want, means in generally, if denominators are there, then only you can apply this concept. Now what I am going to say is, okay, now if denominators are different, you can't apply this method. Okay, so first you should make denominators same, then later you can apply. If you want n number of rational numbers in between any two rational numbers means, okay, now if denominators are same, then what you have to do? You have to multiply with n plus 1. Okay, now like this numbers. Okay, here denominators are same, no? You should multiply with n plus 1 to the both numerator and denominator. So you will get one more rational numbers. Okay, no? So in between that rational numbers you will make it 15. Definitely you will get 15 numbers. Is it clear or not? Suppose you take this example only. Here they are asking 15 rational numbers, but in between 4 and 15 there is no 15 number. Only there are 10 numbers are there. Okay, no? Maximum we can find out 10 numbers. 10 rational numbers or less also we can find. But they are asking 15. So for that what we have to do? We should apply this concept, 10 plus 1 concept. Okay, now. So here 15 they are asking, 15 plus 1, 16. So for both numerator and denominator, you multiply with the 16. You get one rational number. Here also 16 you multiply. You get one more rational number. Denominators will be same. Why? Because 16 into 6, 16 into 6. Denominator will be same. But numerator will be different. In between the numerators, there will be 15 numbers will be. Those 15 numbers you write in denominator 16 into 16. Same. Clear or not? If they ask any type of problems, you will have to solve like in such a manner. So next, how they can ask the problem is, see, suppose you see 2. 2 is a rational number. Very good. 2 is a rational number. If you written part of 2. Okay, it's a irrational number. Clear or not? You should have an idea which are the rational numbers, which are irrational number. Clear or not? So pi. Pi is rational or irrational? Rational number. Why? Because pi can be written as 22 by 7. You simplify at a certain place, it will recur. Recur the decimal places. Decimal places will recur. Clear or not? So now, suppose they may ask to multiply. They will give one rational number and one irrational number. They may ask to multiply or divide or subtract or add, or they can ask anything. Suppose root 2 plus 1 whole square. Okay, they can ask to simplify this. How we will simplify this one? See, just like it is like a plus b whole square. Clear or not? A plus b whole square. What is a plus b whole square formula? A square plus 2ab plus b square. So just to concept that concept you apply. A square means root 2 whole square plus 2 into root 2 into 1 plus 1 square. Okay? Root 2 whole square can be square root will cancel 2. Okay? 2 root 2 plus 1. So this can be written as 3 root 2. This is the simplified answer. Clear or not? Maybe they may ask like this. Root 5 plus 1 into root 5 minus 1. Clear or no? So what will be the answer? Simplify this one. So how to simplify this one? So what you have to do now? It is also like an identity one. A plus b into a minus b. Okay? But it is a square minus b square. Directly you can go with the identity. If you know, you can go with the identity, or else you have to multiply. Binomial into binomial concept you have to apply. See, a square. A square is what? Root 5 whole square minus 1 square. Square root difference. 5 minus 1. So that is 4. The result is 4. Clear or no? The simplified answer is 4. Maybe they can ask in different manner also. Okay, not only this type. Okay, they may ask 6th root of 729. Okay, they may ask to find out the value of this one. So how to find out this? Okay, how to find out this? How to find this? So before this, I'll tell you one thing. See, nth root of a can be written as a to the power of 1 by n. Okay, you should know this formula. If you know this one, easily you can simplify this one. So this you can write it as 729 whole to the power of 1 by 6. So next, what you have to do? Okay, first what you have to do? See, 729 is there. Okay, no? Just you have to find out it is a multiple of any number of like prime factorization you have to do. Okay, no? So for that what you have to do? You have to simplify this 729. See, 729 it is divisible by 3. It can't be divisible by 9. Why? Because the last digit is 9. So it can't be divisible by 2. Why? Because the last digit is 9. So you go with the 3 only. Okay? 3 2s are 6. Okay? 3 4s are 12. 3 3s are 9. Again you can go with the 3. Okay? 3 8s are 24. Again you can go with the 3. Okay? 3 2s are 6. 3 7s are. Again you can go with 3 9s. Again you can go with 2 3s. 9. Okay? You can write most also. 1 means you can stop. How many 3s are there? 1 2 3 4 5 6. So 729 can be written as, okay, 729 can be written as 729 can be written as 3 to the power of 6. So in the place of 729 I can write 3 to the power of 6. So this can be written as 3 to the power of 6 whole to the power of 1 by 6. So by seeing this one, see, you may recall this law. What it is? A to the power of m whole to the power of n can be written as a to the power of m into n. Okay, a to the power of m into n. Just you apply that concept to this one. A to the power of n whole to the power of n. So what you can write? 3 to the power of 6 into 1 by 6. 6 is the answer. So 3 is the answer. Clear or not? Instead of 6, they can ask any value. Okay, we have to solve this. Not only this, maybe they can add something. Sorry. Simplify this. Okay, so this value is 3. You should find out what is the value of this one. So both in between these two plus addition is there. So you should add. Multiplication is there, means we should multiply. Clear or not? They can ask one more number also, they can be a cube root of this. Anything they can ask. Okay, they can extend. Maybe they can ask for the single number or they can ask. Okay, not only addition or subtraction, multiplication or division, cube root of 18. Maybe they can ask this also. Plus 4 They can ask this also. Clear or not? Anytime. They can ask in any manner. Clear? So next, which type they can ask means rationalize the denominator. Okay now? Clearly you observe this. Rationalize the denominator. Means I will take one simple example. I will explain. Clearly you will understand. So how to solve such a problem? See, suppose 1 by 2 plus root 3. Okay now? You will leave it about the numerator. See, they will give this one and they will ask to rationalize the denominator. Means the denominator is not a rational. Just you observe this. Is it a rational number? This is a rational number, but this is a irrational number. Rational plus irrational, then whole thing will become irrational. So totally this one is a irrational number. But here what they are asking, they are asking to rationalize the denominator. So denominator is irrational, so we have to rationalize the denominator. So for that what you have to do, just you should look at the denominator. Is it a monomial or binomial? Monomial, binomial means what? In the denominator only one term is there or more than one term we have. See, clearly two terms are there. Correct or not? One is a rational, one is a irrational. So, in such a case, what you have to do? You have to take the same denominator. The denominator, whatever the denominator is there, the same value you have to take and you should multiply it to the both numerator and denominator. In the rationalizing concept, what you have to do? You should take the same denominator and we have to multiply to the both numerator and denominator. Suppose, you see, 1 by 2 plus root 3. Numerator and denominator is there. No? So the denominator, whatever the denominator is there, no? Same denominator you should take and you should multiply to the both numerator and denominator. The value will not change. Why? Because we are doing the same changes in the both numerator and denominator. So 2 root 3. Okay, 2 root 3. See, one small change. What you have to do? Here in between 2 and root 3, what it is? What is there? Plus is there. So, if it is plus is there means we should take minus. Here also minus. With the same number you should take. If suppose in between these two, minus if you have means, you should take plus. And you should multiply to the both numerator and denominator. Same concept. Any problem, for any problem, the same method you have to do. Like in the rationalizing denominator concept. So you multiply first 1 into anything, the same number will get. Okay, 2 minus root 3. So just look at the denominator, a plus b into a minus b, identity. A square minus b square. A is what? 2 square minus root 3 whole square. Square square get cancelled. Here or not? So 2 minus root 3, numerator is same as it is, 4 minus 3. So this answer is what? 2 minus root 3 divided by 1. See, in the problem, denominator is not a rational. They ask you to rationalize the denominator. They are saying to convert the denominator to rational number. So we convert it. How? By multiplying the suitable number. Clear or not? So instead of this, if it is any other number, so any other type, just to observe. Suppose 3. Okay, 3. Root 5 minus 1. Again, the denominator is not a rational number. Okay, suppose if they have given this one and they ask you to rationalize the denominator. So how to solve this one? I said already, same denominator with a different sign. Okay, so how to solve? 3 into root 5 plus 1 divided by root 5 plus 1 into root 5 minus 1. So here minus, here plus. Okay, here minus is there, the plus you multiply it. So next, you want the simplification. 3 root 5 plus 3 divided by same a minus b into a plus b. a square minus b square. Okay, root 5 whole square minus 1 square. So square root will cancel. Okay, no? The numerator we can't simplify, so write it as it is. Okay, no? So here what you can write 5 minus 1. So this can be written as 3 into root 5 plus 3 divided by 4. Denominator is a rational number. So we rationalize the denominator. Clear or not? So next, how they can ask a problem is, they will give you a rational or irrational number and they may ask to represent that number in the number line. Suppose they may give root 2. They may ask to represent this root 2 in the number line. Or else they may ask to represent this 3 by 2 on the number line. This is irrational. This is a rational. Okay, maybe root 3, maybe root 5. Okay, any number. Okay, any type of question they can ask, and they can ask that number to represent in the number line. Okay, so I take which one? So I will go with the root 2. Okay, so you will solve for any other numbers. So how to represent root 2 on the number line? Maximum they can ask root 2, root 3, root 5 or any like irrational numbers they will ask. Okay, you should know the rational numbers also. 3 by 2, 5 by 2, like such numbers also you should know how to represent those numbers. So for that, what you have to do? First you have to take number line. Okay, so it's a positive number. So just ignore the negative side. So I will start 0 here. So minus 1 is enough because we don't need. So here positive. So 1, 2, and so on. So the first thing what you have to do is, see, they are asking to represent root 2. For that, how I will solve means, see, just to take first one unit. This one you take it as origin O. Okay, no? From there to 1 unit you consider. That is A, point A. Okay, no? From that point, okay, no? One perpendicular line. You draw a perpendicular line. Okay, no? Draw a perpendicular line. Okay, no? The same length, whatever from O to A, 1 unit, no, it is the length 1 unit, if it is 1 centimeter, 1 unit, 1 meter, whatever may be, the length, same length you put it here also. To draw an arc, it's also 1 unit only. Unit. This is also 1 unit. If it is centimeter, meter, millimeter, anything you can take. So this point you consider it as B. So O, B, you join it. See, just you observe OAB is a triangle. Okay, no? OAB is a triangle. That too, right angle triangle. Clear or not? Because I said perpendicular line, you draw a perpendicular line. So this is 90 degree. Clear or not? So here you apply Pythagoras theorem. So just you apply Pythagoras theorem and find out OB value. Okay, no? For 5 minutes you leave the units. So Pythagoras theorem, if you apply to this theorem with this triangle, means what you can write? OB square is equals to OA square plus AB square. OB square we don't know, write as it is OB square. Okay, OA square 1 unit, so 1 square. OAB also 1 square, so 1 plus 1 is equals to 2. I want OB, not OB square. So what I have to do? OB is equals to square root of 2. Clear or not? The square represent right hand side means will become square root. So OB value is what? Root 2. Correct or not? With the help of square, what you have to take? From here to here, the length you have to take and you have to put arc. line which is passing to point B with the help of square. So where it intersects, the value is the intersecting point on the number line is root 2. From O to this point is C. OC value, O to C value will be root 2. If suppose they are asking to find out for root 5. What you have to do? You should take 2 units. Okay? 2 units. Yes, same again on perpendicular line. 1 unit you should join. So this length is 2. Here 1. Okay, same. 2 square is 4, 1 square is 1. 4 plus 1, 5. So square root if we are doing this will become root 5. So again with the help of square root, you draw it. Where it will intersect the number line, that will be the root 5 values. Clear and no? So still more problem is, they may ask, they will give some numbers. In this, which is a rational? Which is a irrational? Is it a rational number or not? Is it a irrational number?